Okay, I think I'm recording now. Hopefully everyone can hear me because if not, I will be very sad. Um, so, oh, there we go. Okay. Um, Everyone, my name is Tim. Um, and I will be leading you through this Unity demo. So hopefully it's helpful. Um, this will be more in depth than the one that I go over in class because of time here that I won't have in class. So we'll kind of be building everything from scratch, but in class and also in the starter files that you'll be provided, there will be complete, well, almost complete code. So if you're afraid of coding or you might get too confused, don't worry about it. Um, so right now, we're going to start from the very beginning, very basics. Um, there will be an itch page where you will be able to download these files from, and hopefully you've already done that part. There's a couple things in here. This is the starter script that we have. Then there's the background code, and then some animations that I'm sorry, the background picture, and some animations that one of my artists on one of my games has gracefully allowed us to use for this demo. We have permission to use them for the demo. Please do not use them for anything else. Okay, great. So the way that we're going to do this, we're going to start by opening up our Unity Hub. You should already have Unity Hub installed as well as for this. Specifically, we're using Unity 6.3 LTS. If you don't have this downloaded, please do so before this continuing this demo. It does take a while to download an editor. So yeah, I don't think anybody will be watching this before class, but if you do, this is your warning now to download this before the class, because otherwise it's not going to happen. Um, okay, so now we're going to create a new project, and then the way we're going to do that is we're going to press the big shiny blue new project button, and it's going to give us a ton of options. We are only making a 2D game, so we are going to use the Universal 2D um, project. It's kind of a template. It'll include a lot of 2D packages and stuff that we'll be able to use for our game, which is nice because then we don't have to download them all individually. Um, that's cool. So we'll use the Universal 2D. Here on the side, it gives you an organization. Doesn't really matter. Mine is just set to this because that's what my GitHub is. For your project name, you can name it whatever you want. I'm going to name it Unity Demo because that's what this is. And then you can choose a location. Your defaulted location might be documents. Feel free to leave it there. Personally, because I work on projects a lot, I like to have them front and center. So I change this to my desktop. Feel free to leave it alone if you don't want to. It's up to you. Because once you create your project, you'll see it in Unity Hub, and it'll be fine. You won't really need to access it like a folder. But anyways, I'm going to create it. It does take a minute for the creation to happen because Unity downloads all of your libraries, all of your packages that it includes with the 2D template. So give it a couple of minutes. Mm, Yeah. All right, so hopefully a couple minutes has elapsed for you and your project is ready to go. It should look like this. Um, Make sure, yeah, okay. Making sure my layout is the same as yours because I have a different layout that I prefer, but we'll go over that in a moment. Um, so this is Unity. Welcome to Unity. It looks like pretty much any editor, game engine, or even very similar aspect to Blender, Maya, things like that. So if you have any experience with those, this is very similar in layout and setup. If not, that's okay. I'm going to go over everything. I'm going to kind of graze over everything because I don't want to be too technical on any one thing unless we're going to use it for this project. But um, in the front and center here, we have the what we call the scene window. There are two options here in the center section here. You can see there's the scene window, there's the game window. The scene window is your editor window. This is how you're going to edit your game. Your game window is your this is essentially what the camera sees. So when you click over to game, you're kind of getting a preview of that specific frame where your camera is at. It won't show you how it will look all the time. In general, it'll just show you the camera view. If you want to know what the game looks like as you're running it, you'll click the play button, and that will give you some indication into Sorry, got distracted for a moment. That'll give you an indication to how the game is running. And we'll go over the play button in a moment. Um, so yeah, that's what these windows are here. You have your typical toolbar here. So if you hover over, you can see we have the view tool, which if you click the view tool, you can click into the scene here. I'm left clicking right now, and you can drag around the scene. Um, you have the move tool, which allows you to move objects. You have the rotate tool, scale tool, the rect tool, and the transform tool. Those are all very straightforward, but we will be using some of these throughout the project. So the move tool, obviously you can move objects with that. Rotate rotates objects. Scale tool scales them, and the rect tool, uh, it. I'll explain the rect tool. We won't use that one. Sorry, I don't want to say the wrong thing with the rect tool, but I believe it's if you're using shapes, you're able to scale the corners with maybe not. Okay, we're gonna ignore that one because I can't remember. Anyways, um, notice how when I clicked on an object here in the scene, you're able to click on these things and it highlights here on the left-hand side. This is what we call the hierarchy window. The hierarchy window shows everything that exists in your game at the moment. This is not including all the sample files or anything that you have in your game. Like if you have music, if you have different code for different things, if you have different characters, it doesn't include any of that yet. It only includes what exists in the scene. And what exists in the scene by default is your main camera, which it's really hard to see your main camera because this is a 2D game. I'm going to go into 3D for a moment. Uh, I'll explain some of these buttons up here, but most of them you won't use them on a regular basis. This 2D button here, you can toggle it into 3D. Even though this is a 2D game, you can see a 3D view. So this is only showing you what the camera sees. So as you can see these lines around this cube here, that's what your camera is seeing. If you move this around, your camera does shift to the side. And I'm using the move tool with these axes here, green moving in the Y direction, red moving in the X direction, and Z in the Z direction for the blue, but Z direction doesn't really do much because, well, it's a 2D game. So you can't really see it moving closer or further away. It's hard to explain this. Ignore it for now. If we're going to move anything at all, we're going to typically be moving them in the up and down or the Y direction, the green direction, or left and right with the X direction. I'm going to reset this. I was moving this around a lot. Oh, wait. There we go. I think that's right. Okay, cool. And then the other object that we have is the light object. Again, the light object is not really too crazy important. Actually, in a 2D game, but in a 3D game, it is important. So we're gonna ignore it for now. So now back to 2D. Some of these things up here, we in the past has been an issue. Just accidentally clicking stuff, which is okay. If you click this first button, this turns it into wireframe draw mode, which you can't really see a difference right now. But there was an incident where it made the camera look really weird. So just make sure that we are always in. I believe we want to be in shaded draw mode. Um, I, when we import assets, if we go into wireframe draw mode, it basically makes everything into lines, and it looks kind of funky. We want to be in shaded draw mode, so we can see like all the shading of all of our assets and everything that we have. Cool. Sorry, I told myself I wasn't going to go into a lot of detail, but I'm doing it. Except. Okay, so that's the hierarchy. When we click anything in the hierarchy too, you might have noticed that there's an inspector window that pops up on the right-hand side. The inspector window has everything to do with that specific object in the game, in the scene. So when you click on an object, there are these things here, these little drop menus. These are called components, and some objects in Unity have different components that are just automatically a part of their architecture in the game. We typically don't want to remove any of these components that are already here because these are how the game is going to function, like at its basic, you know, is basic function, right? So the most important thing we will use though is this transform component for certain game objects. So for might be hard to see in this right now, but I can basically alter in the X, Y, or the X direction, left or right. I can use this here. Oh no, you can see it. I'll use this here, moves that camera view around, so I can do this two ways. So if you put your mouse cursor like right next to the box, you can move this like left and right, and it increases or decreases that value. If you want to change that more drastically or more precisely, you can just type. It'll move in that direction. Positive moves in the right direction, negative moves in the left direction. Zero is centered. Z should be zero. And then the Y direction, again, positive would move up and down. Negative would move, I'm sorry, positive moves up and then negative would move down. Just like math, same maths concepts. Rotation, around the X, we may not see, no, this looks really weird in 2D because you can't really rotate on the X direction um, the same way you would in a 3D game. But if you rotate in the Y direction, you can definitely see like the change. Oh, just kidding. The Z direction, you can see the change. The Z direction, you can see that I rotate negative, it rotates, what is that, clockwise. And if I do it in the right direction, it is counterclockwise. We can rotate stuff in Z. X and Y is what looks weird in a 2D game. And then the scale tool here. The scale tool, you can scale it in any one direction. The camera doesn't really scale well. We'll see this better with our player. And then if you want to lock constraints, you could. So if I wanted to increase things proportionally to each other, then I can lock this constraint here, and it would allow all of these values to change at the same time in the same value, the same rate. But yeah, um, nothing around here is that important. We can ignore all this for now. Um, yeah. One real quick thing, the audio listener on the camera, you always want to have one audio listener in your project. If you have music and there's nobody there to listen to it, then nobody's going to hear it. It's kind of the way you can think of it. Your audio listener should always be there because that's how music will play. So if ever your music's not playing, make sure you didn't delete your audio listener. And then your light, I'm gonna ignore the light. Okay, last thing before we jump into game making. The window down here is our project. This is also the console here. This will show you if you have any errors or warnings. But this here is the project window. And the project window is where we're going to have all of our assets at. There's already some pre-made assets for us. We have a scene folder. There's two ways you can navigate this. You can click this little drop down and click into the folder, or you can double click the folder from this bigger window. What a scene is to Unity is what we call a level when we're playing games. Like I'm trying to beat this level. That's what this is. This is a singular level. You can create multiple scenes. We won't be doing that in this demo, but you could and such. Don't touch these packages. Do not do it because this is how our 2D game runs. This is all stuff that's pre-downloaded. Same thing with our settings. The input map we will be using. This is how our player. This is how Unity 6 and higher does movement. So there's no hard-coded values in this version. So if you have like ways to transform objects left and right, unfortunately Unity 6 doesn't like that. So we will be using the input system action map. More on that later. Cool. If you want to add any windows, you can go up to the top here and you can click Windows. If you accidentally close the window, because there's a possibility of closing a tab by accident, you can go into the window here. Most of our windows that we had seen at the beginning are all in general. I just closed the hierarchy window. There's also some hotkeys that you can learn to quickly access those. Oh, that's annoying. Okay, this is not doing what I wanted to. Oh, because I had to do this. That's why. Okay, great. Back. Oh, I also could have clicked the default layout. Okay, we figured it out. Okay. You can also move these around in any way you want to. For example, I have my layout actually looks like this. This is my default layout. This is Unity's default. That's why I keep this here. Cool. Now let's get into some game making. Yay. Okay. Yeah. Okay. There's nothing else I need to talk about. Okay. So starter files. They'll be uploaded to itch. You'll be able to download them from the itch site. James provides. Yeah. So starter files will look like this here. You can drag everything into it if you want. You can even drag this whole entire folder into your project. It's the easiest way to get files into your project. So I drag this in here. I'm going to drag this into the assets folder. Doesn't really matter where it goes as long as you have it. And it will show this little compiling scripts stuff because there is a script in there. Please ignore the error for now. We will fix these errors. Yeah, we will fix these errors as we get into the code. Mm. And so cool. So now we have our starter files in here. The first thing that we're going to do is we are going to um, build our character. And so the character we're making is Zeus. And Zeus is going to be just running around on a platform and jumping around, and that's what we're going to do. Um, So what we're going to do is we're going to, I already have a Zeus sprite in here. And so what we're going to do is we're going to drag that whole entire file. So let me show you how to slice these real quick. Even though it's already sliced, I want to show. So once we have a Zeus or like any kind of sprite in here, if you have another sprite with animations, this is how you should do it, in my opinion, because this is just the easiest way to do an animated character. Is to have a sprite sheet like this. 4 frames is generally fine. You could do more frames if you want. You could do less. It'll look a little bit choppier, but it'll be okay. I generally do 4 frames, and I believe that our dimensions that we use is 128 by 128. You can do 256 by 256 if you want to, depending on how detailed you want it. But 128 would be fine. When you import this into here for a sprite specifically, you want to make sure that this texture type is set to sprite 2D and UI. It might be set to default when you first throw it in there. Throw it in, put it in the texture type as sprite 2D and UI, because if it's not, it won't show you these options that we need. As you notice here, some of the options changed. So we want to switch that over to sprite 2D and UI. We want to make sure that the sprite mode is set to multiple, because this allows the Unity editor to basically identify the different, it auto identifies the different sprites for us, and it'll help us slice that faster. You'll click apply. Again, ours has already been set to that, so we don't have to change that, but just for when you're starting fresh. So once we've done that, we're going to go into the open sprite editor, and the top here is a button called slice. And we'll set it to automatic slice for us, and then we'll click slice, and it'll actually it will appear with these boxes after you slice the sprite. Again, I thought that this would not be sliced already, but I guess it is. So once you've clicked slice, it will slice those for you. It'll look like this, and then you'll hit apply. And notice at the bottom here now, if I click onto these different sprites, I have Zeus Idol 0, Zeus Idol 1, 2, and 3. So that's cool. Names it for us. And then where you can go ahead and exit the sprite editor. And then it'll look like this with the little triangle. Again, ours already looks like that, but this is what you should see after you go through that whole process. And again, our Zeus walk is similar. It already has that for us. Cool. Now we're going to create our player object. So the way that we're going to do that is we're going to go here into the hierarchy. We're going to click this plus sign. I'm going to create an empty object because there's no player object that Unity gives us. So we have to create our own. We're going to create a player. When you create a new object, it's going to give you just the most basic name of whatever you clicked. So we are going to rename it to player so we easily identify what that is. And notice that the player is only born with the transform. That's perfectly fine. And then there's also nothing going on. You can't see anything. And that's okay. Because right now it's an empty game object. We are going to add some stuff to it. And so the way that we're going to do that is we're going to drag these guys into the frame, or into either the scene view or the hierarchy is fine. So because this is already a sprite sheet that's sliced, we can just drag the whole guy in there. Oh, I lied. Hold on. We're going to click this plus sign, and we're going to select each of these sprite sheets. I'm pressing shift click. I'm shift clicking each of these in order. Notice that they're in order here, 0, 1, 2, 3. I'm going to drag these guys and see how it says multiple on the screen. We want. And it's going to prompt us to do this, create new animation. What does that mean? Well, because we have individual sprites, Unity is automatically going to create an animation for us based on those sprites, which is really cool. I love it. So we're going to do that. This is Zeus Idol, so I'm going to name this Zeus Idol. Name. It's asking where we want to save it. Save it to wherever the default is. And it's going to be inside the project, so that's fine. And we're going to save it there. And cool. I think that it won't let us play test. That's good. So now what we're going to do is it created this little game object for Zeus. We can actually ignore that, delete it. And the reason I'm saying that is because we're gonna set up the animator ourselves, and it'll be okay. Let's do the same thing for Zeus walk. Let's select each one in order. Boom, 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 boom. And 0, 1, 2, 3. Now, the reason I'm saying 0, 1, 2, 3 in that order is because if you do it in a random order, your animation might look weird. Like he might make this middle step twice and then step with his left and his right, and it just looks weird. So just do it in order to get the right animation. And this one's gonna be called Zeus walk. Why don't we have a Zeus run animation? Well, it's because if you increase the speed of the animation, it'll look like he's running. So saves your artist time on animating. Cool. All right, so we just did that. That's pretty much it for the animation part. Now you have an animated Zeus, but we want to see him, right? So the way that we're going to do this is we're going to um, add a component to the player. And so the component that I want to add to the player is actually called an animator. And in the animator, there is going to be a controller. We can do two things. We can click this little circle here and select the animator that we want. Or if you have a ton of animations in here, you really just don't want to look through it, you can search, or you can even just simply drag. There's two things here. So there's the animator. The animator is the box with the sprites, right? And then this is the animation clip. So this is there's a vital difference between the two. There's the controller controls the whole animation, including the transitions and from one animation to another. And we will fix that later. The clip itself is just the animation clip itself. We'll see them both right now, but just so you know, so the runtime animator controller is going to be one of these box things. And we want to set the default. So the default's going to be Zeus idle. We're going to drag that over. And now it's going to change our animator to Zeus idle, which is great. I'm going to pause for a second. Okay. Gonna take a second because I was not seeing anything in the game view. I was like, what's going on? Don't change the camera's position to 0 because then it'll be sitting right on top of your image. That's interesting. Sorry, 2D games are not my 100% my forte. I usually do 3D games. Um, Okay, so if you followed me and you did the camera at 0, Z, don't do that because I was only seeing a blue screen. And I did drag. Okay, let me delete this because I want to. Okay. Um, so what you should see now is you should see Zeus. And when we one more thing that I did that I probably should remove. Sorry, I was doing some testing. You shouldn't see Zeus. And the reason being is because we haven't added anything to create like the visual for him. We've just created an animator. And so the way that we want to see him is we're gonna click down here, add component again. And we're gonna type in a sprite renderer. And I'm sorry, I didn't exactly explain this before when we did the animator stuff, but when we add component, there's tons of components in here that we can use for different things: animation, audio, 2D animation. Remember, we're in 2D, so we want to make sure we do 2D, some physics stuff, and tons of stuff here. So make sure we do 2D animation, and we're going to add. I'm sorry, not 2D animation. I don't know where it's at. We're gonna type in sprite renderer. There it is. And we're gonna add a sprite renderer component. And yeah, so the way that we'll do this is we're gonna just throw in a sprite. It could be any of these because it doesn't necessarily matter because it's gonna be controlled by the animator, but we just need to assign the sprite itself to our Zeus to be able to see him. There he is. Oh, hi, Zeus. And when we click play, I fixed the code too, so I commented everything out so you guys will have this instead. So we can play test. When we click play, notice here that he has his animation going. He's going pretty fast. I'll show you how to real quickly fix that. And the way that we'll do that is we will, there's a couple ways that we could do this. The fastest way to do it is to click on the player object, make sure it's highlighted, and we're going to press Command or Control 6, and that should bring up the animation window here. If that doesn't work, or the hotkeys are different because I'm on MacBook, you can go up here to Window, and we're going to go into Animation, and we're going to find Animation. Not Animator yet, we'll do that later, but Animation. And that'll bring this up. You do have to do this while the either while the player is highlighted or highlight the player. Sometimes I've noticed that if you click out of the window, it sometimes goes away. This time it didn't, which is nice. Um, anyways, so now we have our sprite here, and this is like a timeline, so we can actually play this right now, and we can see how fast that animation is. I don't like that. So we can edit these keystrokes here, and I think that this animation looks good. Spread out quite a bit. I'm gonna do it. You can do it however you want. This is how I'm going to do it. There's a slight jump at the end. It's okay. If you want to smoothen this out somehow, go ahead. We're going to leave it like this because it's fine. And we can do the same thing too with the run animation, which if you, we'll worry about that in a bit. But for now, yeah, that's cool. Um, the way that we could do that is we can go to Zeus Walk, double click that animation. It's not assigned to Zeus yet, but we can, if you prematurely want to just edit these, totally fine. In fact, we'll just do that real quick. We'll edit these guys too. That way it's more spread out, and then we will see that later when we in the walk animation. Okay, great. Sorry, I'm spending a lot of time on animations because it does get confusing. The code won't be as confusing because I'll provide it all for you, but animations is where it gets really confusing. So now that we've done that, we are going to work the last thing, this whole animation stuff before we get into the code is adding some state controllers. And so the way that we're going to do this is we're going to go to Window, and we're going to go to Animation, and we're going to find we're going to find the animator, and it's going to bring up this whole thing here. And when we click on the player, notice that we already have an animation. This is what we call a default state. And there's an entry state, there's an exit state. Right now, our only animation is Zeus idle because Zeus idle, we assigned it to our player, right? And so it's automatically set as our default animation. On play, it'll just start Zeus idle. We want to set up a second transition or a second state for the Zeus walk. So the way that we're going to do this, we're going to right click here in the empty space. We're going to create a state, and we're going to create an empty state. Now, when we click on the state here, again in the inspector here, it's going to have a bunch of blank stuff for us to work on. We're going to call this new state Zeus walk. And our motion is going to be that Zeus walk motion. So again, you could drag and drop, or you can click the little circle, and it should be there, Zeus walk. That's why we did all that stuff earlier, so we have everything ready that we needed. That's that. And in order for this to actually work, we need to link it back to our previous animation because we want to transition from our idle animation to our walk animation. And this is going to be true for anything that you do. So if you're going to be doing like a car, right, you want to have maybe a regular like just driving straight animation. Maybe you want to have animation where the car turns right or turns left. You want to be able to transition between those two at any point in the game based on when you control, right? So what we're going to do is we're going to make a transition, and we're going to right click Zeus idle. We're going to make transition. And it's going to bring up this little arrow. This arrow, we're going to point it at Zeus walk. And then we want to also be able to transition back from walk to idle. So we're going to right click Zeus walk and make a transition back. And so now you should have an arrow going to Zeus walk from Zeus idle, and then a transition going back from Zeus walk to Zeus idle. So one in each direction. Cool. This is the last thing on the animations, and we should be okay. We're going to set what happens in the transition. And the way that we're going to do that is we're going to click on the arrow from Zeus idle to Zeus walk. And we're going to set some parameters for these. Okay. And what that means is a parameter is just a condition for something happening. Okay. So notice that I have a conditions list here, but I don't have any conditions. So we're going to set one here in the parameters tab at the top. We're only going to do one condition, and the condition is going to be a trigger. You can have different I lied. We're not doing a trigger. We're doing a float. You can have different kinds of parameters. There's floats, integers, booleans, which is true, false, trigger, right? This is more for the programmers. Programmers is your part. You're going to set a float parameter. We're going to call it speed. And we are going to leave the parameter at 0 for now because we will set specific parameter value in our transition. So speed is our only one. We're going to click here. Our arrow from Zeus idle to Zeus walk, and we're going to add a condition. The condition is going to be speed, and we're going to have the speed greater than 0.1 because, oops, because if Zeus is moving at all, we want him to be walking, right? So speed has to be greater than 0.1 in order for him to walk. In order for him to walk, we'll have the Zeus animation of walk pair. We're also going to uncheck has exit time because if you don't, what ends up happening is the animation will be based on the length of the animation rather than the action of the players. So if my animation for whatever reason is like 30 seconds long, then the animation will play for the duration of that or for the duration of that regardless of what the input is. And we don't want that. So we want to make sure that we uncheck has exit time. And then similarly, when we go from Zeus walk to Zeus idle, we're going to add speed. We're going to do we're going to change speed to less than. Checking my notes, making sure. Yeah, less than 0.1 because anything less than 0.1 is 0. And in our case, floats can't be negative, so or speed won't be negative, so we'll be solid at 0. He will automatically be idling. Yeah. Okay, great. I'm gonna pause for a second to take a drink of water. Okay. I'm just making sure everything looks good as I'm taking pauses here and there as I see errors pop up. That error, if you had that error, go ahead and feel free to clear it. It should be okay. The reason it was showing is because I think because I added a condition prior to adding a variable, a speed parameter. So we should be okay. If anything pops up later, we will fix it at the moment. But coding is all about errors, right? And then fixing them. Okay. So now we're, oh, yeah. Make sure on the transition back from walk to idle, we also uncheck has exit time. Um, Now we're done with animations. The last thing we had to do is set up our code. And this is honestly not as difficult because I'm providing most of it for you. But I will go line by line for my coders. Feel free to stick around for the part where I go line by line. You can understand what's going on. Um, I want to add a background. So we're going to add a background into here. And the way that I did that is just grabbing the background that I have and just dragging and dropping it. This is the free, royalty-free, non-generative AI image that I got from Pixabay. So I'm just throwing out the credits there. I use Pixabay a lot for stuff. I make sure to screen for AI content. So I promise, to the best of my knowledge, this is not an AI generated image. Throwing that out there. Okay. And so let's see. So we have our background here. And now this is the platformer, right? We want to throw out some platforms in there. And right now, when we click play, nothing happens because, well, nothing's programmed to happen. Oh, something's happening there. And I'll show you guys what that is right now. But notice that nothing's happening. If I move around, we don't do anything. And so here's what we're going to do. To fix that layering issue, I'm going to click on the background and I'm going to make sure that my background is in layer 0 always. So that's good. And then our player, we want to always have it in a higher layer than that. I always default to like 50 because if I add anything in there, it will usually be in the background of Zeus, or sorry, I say Zeus, but I mean of our player, not in the but not in the background of the background itself. So now notice when I play it, he's not doing that clipping thing. That's important. I want to add some platforms here. And so I'm going to do that in the easiest way is by adding in a 2D object. You can design these as sprites too. This will work in the same way, except you'll just drag and drop the sprite into it. If you have a sprite of something. For me, I'm just going to create an object. So we're going to create a 2D object. I'm going to create a sprite object and I'm going to create a square. Now you can't see the square for the same issue that we just addressed. So I'm going to change the layering of this square to 5 and notice that it drops in here. There's that rect tool. That was right. Yeah, you can drag it on the corners and it scales it. Okay, cool. Um, so we are going to use the scale tool, and I'm going to drag this along the x-axis to make it just to drag it on the x-axis in both directions. Um, and I'm going to position this by clicking the move tool and this little blue square here, and I can just drag this around the screen. You can also use this, or you can type in the values if you know what the values are. I'm just going to do it that way. Very important. And then I want to make sure that Zeus is also on top of this in some fashion. So that's good. Cool. Now, to get our player to interact with everything, I need to add a. Can I be heard? Okay. Sorry, I'm checking my mic. It would suck if this whole thing was for nothing. Okay. Um, so there's two things that we need to add. So first we need the character to interact with the physics. So let's interact with the physics by adding what we call a rigid body. Now it's important that we add a 2D rigid body, not a rigid body, because this is for 3D games. We're doing 2D, so we need to do the 2D rigid body. And you'll see here it has mass, it has gravity, and that's all we really care about. Um, if you had an object like a ball or something and you were adding a rigid body to it, you can also add a material to make it look like a ball if you have a material that you design. We don't need that because we have a sprite. Um, so you can adjust the mass to make him heavier. You can adjust the gravity to make him lighter, so he floats more. Things like that. That's what we can do with that. This is starting to get a little cluttered. I'm going to reduce these a little bit because we're going to be kind of done with using these. We're going to be expanding this. So I'm going to use this little triangle here to reduce these components. And yeah, so that's that. Let's add also what we call a box or a collider. So there's different types of colliders. There's box colliders, there's capsule colliders, circle colliders. There's tons of colliders. There's even mesh colliders that can go over the mesh of an object if you're working in 3D. Pretty cool. Again, they all have their 3D, 2D versions. Let's make sure we're using 2D. For Zeus, we could use just a little box collider. And notice that it actually takes the shape of the sprite. So super cool and super simple. But if you wanted to edit it, you can edit the collider by clicking this little network looking thing. And you can make the collider bigger or smaller, however you want. I like the way that it did it, so I'm going to kind of try to get back to that. And then just click out of it to go back to normal. Great. Okay. One more thing that we're going to need to add is we're going to need to add a collider to our platforms because at the moment, if we click play, Zeus will fall and he will not come back. We don't want that. We want to add a collider to the platform too, as well. You can do a blocks collider as well. So that way you can't really see it, but it's there. That way when we do press play, um, Zeus falls onto it. Yay, that's what we want. Great. We do this a couple more times. If you already set it up how you want it, then you can actually press Command D and duplicate this box. And click Command D. Great. And now it'll create a second box on top, and we can move this. Do it one more time so I can create 3 boxes, three platforms. Yeah. So this is like I said, this is the easy way. But when you do a sprite in if you design a sprite, this works exactly the same. Just drag it in, add some colliders to it, and it'll function exactly the same way. You don't want to add a rigid body to your platforms because if you add a rigid body, then well, the platforms will fall and they'll interact with the gravity. We don't want that. They'll be static here. Great. I think the art is done. Okay. Now it's time for programming. Um, One more thing that we're gonna do that we're gonna need. Actually, I'll get into it when we do programming. Um, but train of thought. Um, we are going to add 2 more objects to our player, or 2 more components to our player. We are going to add the player input. And the player input, this is all very confusing. Ignore all of it, literally for now. Just very basic. We're going to use the input action map Unity provided to us. I'm going to go back to our assets folder, the root of the assets folder, and there's an input map here that I showed at the beginning. We're going to drag and drop that into this guy. Okay. And what this is Unity has a map where we can use different action maps for different things. Notice that it already comes with player and UI. And what it does is um, it maps certain buttons to our buttons. Really vague, I know. But for example, like if you go click into the player action map and the action is move, I see here move is already set to WASD. Okay. And so rather than us going into the code and adjusting moving up with W, S, A, and D or up, down, left, the arrows, um, and fixing that in the code. So previously we would have to do hard coded values where we say, okay, well, move is going to be with WASD. So I have to say like get key, I don't know, get key down and W. And then when you get the key down W, then you have this specific movement that happens when you press W. Like instead of having to do each of those, Unity maps everything for us. So rather than using this, we'll use a function later called onMove that will say onMove. So no matter what button we set for move, it's just going to have onMove is going to do whatever without us having to change the code. We can just go in here and change the buttons. And if we want to map different buttons instead later on, it just makes it super easy. And Unity gives us all of these options already mapped for us, so we don't even have to map it. We just gotta code it. Okay. I'm gonna save because I don't think I changed anything. Cool. Anyways, that was that. I really apologize if this is getting long. It just happens. The last thing I'm gonna do is I'm gonna assign a player controller. And sorry, player controller. Yeah. Okay. Player controller. It should show up here. Why it's not for me. Okay. For some reason, it's not showing up. But what you could do is you can click and drag this script and hover it over the player script because the script class cannot be found. Oh, I know why that's happened. Okay, so we're going to open our script first. Sorry, guys. This is a different way that I did it last semester, so I'm a little different. Okay, what we're going to do is I have everything commented out, and I'm going to delete these comments. The beginning, this very first line, I'm going to delete it, and then I'm going to go all the way to the very end. There's another one here. We're going to delete that too. That's how we were able to get past the errors and being able to edit this. Okay. Um, So now that we have that, let's just start editing this. So right now we have using these using statements at the top. We're going to add a second using statement and we're going to call it, it's going to be using Unity engine dot input system. And what this does is this accesses that input system that we had uh, assigned to the player. And then we're going to add some variables that we're going to reference in the inspector. And I'll show you guys that in a moment. Um, we're going to declare a couple variables. This is not going to be very long, I promise. We are going to um, declare a public variable. It's going to be a float variable. And we are going to declare our speed variable. So speed is equal to whatever. So I'm going to put it as 5. And since it's a float, we have to include the f at the end. So 5f. We're going to create another one called jump force. Same exact way, but instead of the variable name, it's going to be called jump force. And we're going to call this 25f. We also need to get the rigid body from the player. So we're going to declare rigid body RB. And this is going to help us identify help the code reference the character's rigid body so it knows which rigid body it is affecting with the speed and the jump force. And then we're also going to have another variable, public float. I'm sorry, I don't know why I did that. We're going to access the animator and we're going to call it animator so we can access the player's animator. Cool. The rest of it is already done for you. For the people that don't want to listen to the code part, I will go back to our game and show you how to connect everything. Will be done. Stay after that if you want to hear what the like line by line breakdown is. So I press Command S or Control S. That saves our. Oh, actually, I'm sorry. We have two more things that we have to do. We have to declare our move input here, which stores our horizontal input, and then we also have to check to see if the ground is there in order for our jump to work. Yeah. So again, we'll go over that more later. And I noticed that because there is an error at the bottom. Great. If you did everything correctly, your errors will go away and you should be okay. The last thing we got to do is assign this player controller. Now it shows up when I type add component, type in player controller, or you can drag the script directly to the player. Great. And now you can see too here, speed and jump force are in our inspector. So now we don't have to edit the code if we just want to edit the speed and the jump force. Cool, huh? Now let's make sure everything works. So press play. And now pressing the D AWSD keys, there's idles when you don't press anything, and when you move, the only thing that doesn't work is the jump. And the reason that is because there is one thing that we have to do. Remember, we had bool grounded. That's checking if grounded is true or false. And there's code in there that's telling you that. The way that we have to do this is we have to click on our. So what it's doing is it's checking for a tag, and the tag is that this platform is the ground. And so we want to go up here right under the name and we want to change this to ground. However, there's not a ground tag by default. So we're going to add a tag. I'm going to prop up this tags list here. We're going to throw in ground. And now when we go back to the square, we're going to tag ground and it should work. Fingers crossed. Oh, it worked. Okay. It worked a little too well. And so now we can just edit. I'm gonna lower that jump force a lot. I'm gonna lower that jump force to 10. I did that on purpose, but I forgot that I did. And so now it works. And so now when you run around, you're able to jump from one platform to the next. Notice that I can't jump on this next platform because I didn't change it to grounded. Oh, there's one last thing that I want to share before I go into the coding again. Notice that Zeus is like flipping around, flopping around. He's not supposed to do that. He's not a fish. We could fix that by going to player, go to your sprite renderer component, and go to your rigid body component. Go to constraints, and you're gonna freeze that Z rotation so that way he doesn't rotate along the Z. And then this keeps your player upright all the time, regardless of what hits him or what he hits. That's good. We're done. Yay, we have a game, 2D platformer. I'm gonna tag each of these ground, and you're able to now play your platform. Very simple platformer. The jump is still a little bit high. One very last thing that I'm going to mention about this is that notice that when I click out of this, it goes to this like lighter gray. When I click into playtest, it goes into the darker gray. You want to make sure that you are not in playtest mode like this, because if you edit anything in this at all, with a few exceptions, majority of it will not save. Like if I was to go in here and maybe I wanted to change the jump force to like 1,000 for some stupid reason, and then I'm here and I'm playtesting it. I'm like, oh my god, I love it. I love that when I press spacebar, Zeus just completely vanishes and is nowhere to be seen. When I stop, notice that it goes back to 10. That's because this is a saved state. It's not, or it's sorry, it's not a state where it saves it. That information is just a playtest. So you're able to edit stuff and see how it interacts, but you can't actually, it actually won't do anything for you. So it's good to use if you want to like just see in the moment without constantly pressing start, stop, if something changes. But if you're gonna do that for anything really, I recommend either just really going really quickly back into it and changing it, or writing down some notes and saying like, okay, change jump force to 1,000. I liked it. That way you know that that's what you want to do when you exit out of the scene playtest mode. That's it for all of you that just wanted the quick rundown with the code. And I say quick loosely because this was a long video and I apologize, but I hope it was helpful. Yeah, that's pretty much it. For those of you that wanted to see the code, though, I'm going to go back into this code real quick and I'm going to explain these line by line and what's going on. I do have my notes next to me so that way I don't misinterpret anything. Um, I forget. So, like I said before, when we start a Unity script, it's going to give us automatically these here using Unity engine input system. All of our declarations at top are going to be given to us, as well as a start and an update method. Those will automatically be there. Everything else is added into here. So we declared all of our variables as public. The reason that we did this is because it'll show up. Oops, it'll show up in the editor here. So notice that on the script component here, I can see jump force because it's public. I can see jump force because it's public. If they weren't public, you would have to go into the code and manually change these. That's why we do public. So you can do this for a lot of things. I can even do public bull is grounded. And what that'll do is kind of interesting because it'll show here. And then when we go into our code, I'm sorry, when we go into our playtest, it'll actually show us that variable, it's grounded. And now when we jump, it's not grounded. And that's what's happening in the background there. And it's nice. That's kind of a nice feature because if we're debugging and you want to know why he's not jumping, well, you want to make sure that it's reading the ground. Because if it's not reading the ground, if for some reason I'm on this platform and it doesn't show grounded as checked, right? I can't do anything but change on this. That's kind of the idea behind that. Down here, I have in the start. So at the start of the game, I want to get the component of the character of the player that's the rigid body component. And the way that we could do that is we have this get component method. And we can get any component that we want and assign it a variable, right? So we assigned a variable earlier, rigid body 2D. RB is going to be the component of the player that is the rigid body 2D. And that is why we use the rigid body 2D specifically too, because if we didn't have rigid body 2D, then it wouldn't be able to access that component because it's not aligned. Same thing with the animator, get component animator. So now we have those variables stored that we can use later. In the update and start, important, start only happens once, beginning when you press start. It'll also show you here. Start is called just before any of the update methods. It's called for the first time. And then update is called once every frame. So anything that you want to happen on a consistent basis, you want to throw it into your update method here. There's also late update methods, which is useful for like cameras and stuff like that, but we're not going to go into that this time. So I have rb.linear velocity is equal to new vector 2 move input times speed. So Unity has these particular methods here, and I don't know why it's not working when I hover. Usually when you let me try it right here. When you declare a variable, I don't know why it's not doing it. Okay, sorry. We have a vector 2 movement here, and our vector 2 movement is taking our vector 2 method is taking in our move input from the player's controller, and we're multiplying it by the speed. And that's why increasing or decreasing the speed would increase or decrease the amount that it moves. And then it's applying that movement to the horizontal movement using the physics velocity. And so we're saying that if our move input is greater than 0, then we're going to transform our character to the right. Otherwise, if it's less than 0, we're going to transport to the left. And I think this is also flipping this right here is flipping our sprite too. And then we send that movement to the animator. So we're setting float speed. And we're taking the absolute value of that input. So that way it converts it to the right float. What do I say? The right value for our float parameter to read. So notice that we're setting our float speed. That's our parameter that we had created earlier. And we are feeding it this value. So our absolute value of our move input is going to be the speed. So anything greater than 0.1, or even if it's negative 0.1, it's taking the absolute value of that and translating that for our parameter to read at speed, so that way it's able to read the animation. Mm, That's fun. Okay. Now this is where we get to our player input stuff. So this is called when our sorry, when our player input happens. So on move, on jump, we have on jump as well. There's nothing else that we use, but if we had like on melee or on attack, whatever you have in there in combat, you can create new actions too and be able to create these, and it will reference your player controller. Notice that when you hover over this, it shows you player controller dot on jump. This one's player controller dot on move. So we'll do that. Okay, on move here, we are taking in a vector2 input, and we are assigning that we are taking the x value, sorry, of that input. And then say here on jump, we're checking if grounded. That's when that whole boolean happens. If not grounded, return. Otherwise, it's going to run this here, which is giving us our it's changing our linear velocity in the x direction with our jump force. Um, and then here, sorry, this is a duplicate. This shouldn't be here. It's here. I don't know why it didn't give me an error. Interesting. That shouldn't even be there. Okay, cool. So you won't see the second one. Um, Great. This last one here is on collision enter 2D. So this is when the player touches something. Collision enter, meaning that the collider of the player is entering the collider of something else. So if collider, COL is collider, right? If collider.gameObject.compare tag grounded. So this is what this is doing is this is comparing the tag of the ground or sorry, it is comparing the collider of the game object and making sure that it has a tag ground, then grounded equals true. So this is saying that the player is standing on the platform, their collider is interacting with or is entering, quote unquote, the collider of the game object that has the tag ground, and it's saying that the grounded is true. Okay. And then on collision exit is the opposite. It's saying that if the collider that is on the game object has the tag ground and it's being exited, then you're switching ground to false. This is how our jump works. Mm. So yeah, sorry, that was a really rusty like explanation. I hope it wasn't super confusing. A lot of these are just standard Unity movement. It's a little bit like so hard to explain sometimes, but I hope that that's helpful in understanding some of this stuff. I get a lot of my scripts from Medium. There are a lot of blog posters about Unity on Medium that you could use to look at these things. But yeah, anyways, I hope this was helpful. Again, this is really long. I need to see everybody in class.